This video is all about graphing lines. Here is an example of a line, 2x plus 3. We're going to learn how to graph this line using an XY chart by plugging in values. We're going to learn how to graph this line by using a visual trick, where you can just look at the slope and y-intercept to graph it. We'll also be looking at intercepts, and what that means is, very briefly, is if I have a line on the coordinate plane, I will be able to find where they intercept the x-axis and where it intercepts the y-axis to be able to plot those points and then draw a line through them to graph the line. And that is what we are going to learn today. So here is our video outline. First, we're going to look at a couple different functions so that we can make sure we understand what we're looking at is an actual equation of a line and not the equation of something else. Then we're going to graph lines using an XY chart, then using the trick, then by looking at intercepts. Next slide. All right, so different functions. So we're going to be graphing lines. Right? Lines are functions. A function is a graph where each input has exactly one output, meaning that if I give you an x value, it will only have one y value each and every time. Next slide. So these are different functions that you will come across, right? And as you get into higher math, there would be definitely more functions. All right, but how do we know that what we're looking at is a line? If you notice, this is y equals x. That's the equation, the general equation of a line. Okay, and it really is, it's y equals x plus 0 because it's plus nothing. So that's why it just writes plus x. That's why we're writing just x, So y equals x. Same thing for the next one. Y equals x squared plus 0. And then y equals x cubed plus 0. They all have a 0 right there because look, they all start in the middle. Okay, but how do we know that it's an equation of a line? Well, if you look at how the x looks, you'll be able to tell. This one says y equals x to the first power. This one says y equals x to the second power. And this one says y equals x to the third power. Any equation that has y equals x to the first power, it's a line. For example, y equals 2x minus 3. This is still x to the 1, so to the first power. If I write y equals negative 3x plus 2, this is still to the first power. Whether or not I see a 1, it's still there. Now, for this graph right here, it says y equals x squared. There's a square there. So that's not a line. It makes this parabola shape, which is like a U. If I have y equals x cubed, okay, then I have a 3 as my exponent here. It's not to the first power like a line. A line is to the first power. But the cubic function is to the third power, so that's why it has this weird little jump in the middle, as you can see. But we're not going to be looking at these ones. We're only going to be focusing on the line. But I wanted to make sure that you understood the difference. So just to clarify, I'm going to put 3 different equations here, and I want you to figure out which one is a line. Let's see. Which one is a line? Oh, let me put numbers in front just to confuse you. There you go. Which one of those is a line? All right, wrap up your thinking. All right, hopefully you said this one because this is the only one that's to the first power. This is squared, so it's going to look like a U shape. This one is cubed, so it's going to look like that. Okay? All right, next slide. All right, so we just looked at the different functions. We are only concerned about these to the first power. So equations to the first power, so like 3x minus 2. Okay, now let's actually start graphing this line. Okay, let's make sure we know how to do that. And how we're going to do that is using an XY chart. So what it says is all you would do is plug these x values. These are x values, -1, 0, 1. You're going to plug them into this equation. Y equals 2x plus 1. That's an equation of a line. Look, it's to the first power. Okay, you're going to plug it in there and figure out what the new y value is. And then that's going to turn into a coordinate. So let's go ahead and try that out. Okay, so I'm going to put it over here. Y equals 2x plus 1. So my x is -1. So I'm going to find out what my y is when I plug in -1 for x. Here it is. I plugged it in. Oops. Here it is. I plugged it in. So then y equals 2 times -1 is -2 plus 1. Okay. So y equals -1. So I'm going to put -1 right there in the chart. Okay. Let me find some space for the next one. So y equals, I'm going to rewrite the original equation so that I know I'm plugging it into the correct equation. And now I'm going to plug in 0. Okay, y equals 2 times 0 plus 1. When you plug in numbers, use parentheses, okay, because it shows that you're plugging something in. So y equals 2 times 0 is 0 plus 1. Y equals 1. Okay, so I'm going to go ahead and put 1 right here. So when x is 0, the y value is 1. Now our last one, I got to plug in 1. Y equals 2x plus 1. That's our original equation. Y equals 2 times 1 plus 1. Y equals 2 times 1 is 2 plus 1. So y equals 3. Okay. So what this is saying is when x is -1, y is -1. When x is 0, y is 1. When x is 1, y is 3. So these turn into coordinates. Hopefully you remember how to graph. Okay, so the first one we're going to plot is -1, -1. Start at 0. Always do the x first, which is left to right. So 1 to the left. And then the y is up and down, so I'm going to go down 1. So here's my first point right there. Okay, now my next point is 0, 1. So start at 0, go up 1. There we go. And our next one is 1, 3. So start at 0, go over to the right 1, then up 3. 1, 2, 3. There we go. And now we have a line that we can draw. Try drawing it as straight as possible. If you have some kind of straight edge like a ruler or the edge of your binder or a book nearby, that can really help make a straight line. Okay. If it's a little wobbly, like as you can tell, mine's a little shaky, that's okay. As long as you don't have something that looks like this. That's definitely not a line. Okay, so please make sure that you draw it as straight as you can and all the way through. Try to make sure it touches all 3 points. If you need to, draw a little bit at a time, like this. Okay, and that's pretty good. Make sure it goes to the edges of the graph with arrows, because a line goes on forever. It never stops. Okay, lines go on forever. Okay, so don't draw something like this. Don't say, okay, like that, and then stop like this. Don't do that. It has to go all the way to the edges of the graph. Okay, to imply that it goes on forever. All right, next slide. All right, here's another one. Okay, so I need to graph this line, y equals -3x minus 1. So I'm just going to plug this stuff in. So y equals -3 times -1 minus 1. Y equals -3 times -1 is 3 minus 1. So y equals 2. Okay, let's try the next one. So y equals -3 times 0 minus 1. Y equals 0 minus 1. Y equals -1. Next one. y equals negative 3x minus 1, y equals negative 3 times 1 minus 1, y equals negative 3 minus 1, so y equals negative 4. Okay, and let me just check my work. Positive 3, there we go. Okay, looks pretty good. So remember, now these turn into coordinates. Okay, I had to fill in my XY chart, but now they turn into coordinates. Coordinates are the points. So negative 1, start at 0, 0, go to negative 1 to the left and up 2. Okay, and then go to 0, go down 1 to negative 1. And then start at 0, go to 1 to the right, go down 4. 1, 2, 3, 4. Right there. And it should make a straight line. Right? If you get a point and it does not make a straight line, check one of your answers. Check that work for that point to see if you got it wrong. Okay, because it will make a straight line. All you need is 2 points to make a line, but as you can see, I'm giving you negative 1, 0, and 1 because I want to see what happens directly on the y-axis. I want to see what happens to the left of it and to the right side of it. Okay, so that's why I'm giving you negative 1, 0, and 1. Really, you can plug in any point, but not all points will be on this small graph. Like if you plugged in 10, it would be y equals negative 3 times 10 minus 1, y equals negative 30 minus 1, y equals negative 31. So then your coordinate would be 10, negative 31. Well, there's no 10 on this graph. This is a small coordinate plane, and there's no negative 31. Okay, so I'm picking points that will definitely fit this graph for you. And will show us what's happening to the left of the graph, to the left of the y-axis, and to the right of it, and on the y-axis. Okay, so I'm going to give you one to practice on your own. All right, when I show it to you, press pause, try it out, and then come back when you're done. Okay, go ahead and practice that. Press pause. All right, welcome back. So we have y equals 2x minus 3, y equals 2 times negative 1 minus 3, y equals negative 2 minus 3, y equals negative 5. Negative 5. All right. Now y equals 2 times 0 minus 3, y equals 0 minus 3, y equals minus 3. As you can see, I'm circling my answers here, and that's purely for organization so that it makes it easy for me to find my answer to the work when I plug in that x value. Y equals 2 minus 3, y equals negative 1. So at this point, remember, these turn into coordinates, so now I can plot them. It's always start in the middle at 0, 0. Left negative 1, down to negative 5. If you're forgetting how to plot points, please see me so that I can help you out. Okay, you learn how to plot points in elementary school. We definitely go over it in 6th grade math, right, and see it again in 7th. So it's an expectation that you know how to plot these points. Okay, there we go. So when asked to graph a line, you won't always be given an XY chart. So I should say you won't always. Okay, you will not always be given an XY chart. You may have to create it yourself, which means that you may need to create your own inputs, your own X values to plug into the function. You can use the ones that I always like to use, like if you notice all of our examples did negative 1, 0, and 1. And again, the purpose of that was so that we knew what was happening on the y-axis, we knew what was happening to the left of the y-axis, and what was happening to the right of the y-axis. Okay, you only need 2 points to make a line, but remember, when picking values, it's best to pick a positive and a negative so that you can clearly see it across the graph. Okay. All right, last one for you to practice using the XY chart. Okay, so go ahead and figure out how to graph this line right here. Okay, so it's y equals negative x plus 1. Go ahead and graph that, pick your own points or pick the same points I did. When I go over this one, I'll use negative 1, 0, 1. So go ahead and see what you get. All right, press pause, come back. All right, so I'm going to use these ones. If you use different numbers, that's okay. You're going to get different numbers than me, but no matter what, those points will be somewhere on that line, no matter what. Okay, now try to show you that. So let me see. I'm going to write, okay, y equals negative. I'm going to plug in x. My x is -1, so it has to look like this because it was y equals negative x plus 1. We're plugging into the x, so the negative's on the outside, so it has to look like this. So y equals -1 times -1, or if you remember from 6th grade math, that's actually the notation of opposite. The opposite of -1 is +1. A negative times a negative is positive, so +1, and then plus 1. So y equals 2. Okay. Now y equals negative x plus 1. So y equals -0 plus 1. -0 is just 0 plus 1. Y equals 1. Okay, next one. Y equals -x plus 1. Y equals negative. I'm going to plug in 1 for x plus 1. Remember, the negative's on the outside. So y equals -1 plus 1. So y equals 0. And that's okay. That can happen. Okay, so let's see. Okay, -1, +2. Okay, 0, 1. Yep. 1, 0. Ooh, I drew that little line there by accident. Okay, so there we go. Now, I'm going to try drawing as straight a line as possible. And I'm going to show you how whatever point you picked, it will be somewhere on this line. Okay, so let me show you. Okay, so let's say if you did, if you plugged in 2. Okay, let me add that chart. If you plugged in 2, what will happen? So y equals -2 plus 1. Y equals negative times a +2 is -2 plus 1. Y equals -1. So let's see what that will look like. Okay, so I go to 2, -1. Ooh, yep. My line's a little shaky, but that's where the line would be, crossing through that one point. So no matter which point you choose, as long as you do the math correctly, it will be somewhere on that line because you're using that linear equation right here. You're using the line that's given to you to plug in points. So if you're doing the math correct, it will be a point on that line. All right, next slide. All right, so here's our lesson video outline. We looked at the different functions. Remember, all lines only have an exponent of 1. Okay, and it can be plus or minus 2, it doesn't matter, as long as it's to the 1 power. All right, remember, that's the same thing as just writing y equals 3x plus 2. We're looking at lines. We graphed using an XY chart. Now we're going to use a trick, and then after, use intercepts. So part 3. Well, in order to use a trick, the trick that we're going to use by just looking at a line like this, 2x plus 3, within maybe less than 10 seconds, you'll be able to graph that line without having to plug in any points like that XY chart. Okay, this is what the trick is. But this part of the lesson teaches you the trick. But we need to make sure we understand vocabulary first. Okay, so when I have the equation of a line, there's something called the slope and the y-intercept that I can directly see by looking at this equation. Okay, my slope is the number in front of the variable. It's the rate of change, like rise over run. Okay, so if I have a slope of 2, what that really is saying that each time I go up 2, up 2, up 2, up 2. Okay, and it's really, it says rise over run. How do I make 2 into a fraction? I put it over 1. So it's saying up 2 over 1, up 2 over 1. You rise 2 and you run once. Okay, that's what slope is. Don't worry, we'll have some more examples on that. Now the next thing is the y-intercept. This is the y-intercept, wherever it crosses the y-axis, when x is 0. If you notice, every time you plugged in 0, if you did or didn't, look, 0, I plugged in 0, the answer is 1. 1. Let's look at another one. I plugged in 0, -3, -3. Let's look at another one. I plugged in 0, got -1, -1, because that's my y-intercept automatically. Whenever I plug in 0, I get this right here. Okay, I get the number that was there, my constant. Okay, my constant. So it's where the function crosses the y-axis. Okay, so where it crosses. The other vocabulary word you're going to need to know, but it's more for later. You don't need it for the trick. It's the opposite of the y-intercept. It's where, like for example, like here it says it's going to cross at 3, so I can go up 3. Okay, that means whatever this line is, it's going to cross at 3 somewhere. No matter where, the slope helps me determine which direction it's coming from, but it will always cross through 3 if the y-intercept is 3. But what the x-intercept does is tell me a little more information. If the x-intercept is where it crosses, where y equals 0, that means it's somewhere right here where it crosses. So say if it crossed right there, if I have both points, then I can do the y-intercept. That's what, I mean, that we can graph the line, I mean. And that's what we're going to see later after I teach you the trick. So you'll learn that more later. Okay, x-intercept is where it crosses the x-axis. Y-intercept is where it crosses the y-axis. So let's look at that vocabulary a little more. All you need to do is look at two things, the slope and the y-intercept. Okay, slope is the number in front of x. Y-intercept is the constant. Okay, the number that's always in front of an x anyways is called the coefficient. But it's also the slope when you're looking at an equation of the line. If you notice, I kept saying y equals, like I was saying, just making up examples, 2x minus 2. Well, because that models this. The actual formal equation of a line is y equals mx plus b, where m stands for slope and b stands for y-intercept. Okay, that's just the fancy math language, the algebraic language of an equation of a line. So for the trick, what you're going to want to do is plot the y-intercept automatically. So look for the constant, find 6 where it is on the y-axis, where this is y, this is x. So wherever 6 is, you're going to automatically put that point. But then you're going to look at the slope. And then you'll see, okay, I'm going to go up 4 over 1, up 4 over 1. But let's talk about that slope a little more before we actually start using this trick to make sure we understand. So before we actually start graphing, let's make sure we understand how the slope works. And how we're going to do that is to explain it in word form and write it down before we actually start using the trick. Okay, so if I'm looking at this equation, this is my y-intercept. I'll start off at -6, but what I'm concerned about is this 3. Okay, well, I'm going to turn that into a fraction. Okay, so it's really 3 over 1. And what I'm going to say is up 3 over 1. I'm going to go up 3 and then to the right 1. So how would I say this one? Up 4, make it a fraction, over to the right 1. What about this one? Well, do you see how it's a negative? Okay. The top part represents going up and down. So if it's positive, we go up. If it's negative, we go down. So it's going to be down 5. This bottom one represents going left or right. If it is positive, we're going to go to the right. If this number is negative, we're going to go to the left. Whoa, how would it be negative? We'll see that soon. Okay, so let's look at 3. So it's down 5 to the right. So over to the right, 1. Okay, so let's fix number 2. So up 4 over to the right. 1. And even number 1 we can change. Now that we know the right way of saying it, up 3 to the right, over to the right. Let's see, over to the right, over to the right 1, because it's a positive 1 on the bottom. Now let's look at 4. Okay, it's already a fraction. So up 2, over to the right, 3. Okay, now for 5, how would you say that one? Think about it. Hopefully you said up 1 to the right 7. But what if I did this? If I put a negative on the 1, what would you say? Down 1 to the right 7. Well, what if I put a negative on the bottom? You would say up 1 to the left 7. Okay, you're going to see stuff like that. So now that we had some practice in word form, let's get to graphing. Okay, so I have this graph, y equals 2x plus 1. According to the trick, I need to do my y-intercept first, then my slope. So my y-intercept is positive 1, so I'm going to put a big dot on positive 1. And then my slope is 2, so I'm going to make it a fraction. Okay, so up 2 to the right 1. Use little notations if you want. Up 2 to the right 1. Whoa, only 2 points make a line, but I want to make an exact line. So I'm going to go up 2 again, because the slope is repeating. Okay, look. Look what a great line that is. Very, very accurate. And remember, we got to go all the way to the edges of the graph. Okay, there we go. Perfect. Let's look at our next one. So y equals negative 3x minus 1. Y-intercept is at negative 1. So find the y-axis and put it at negative 1. Then my slope is negative 3, but I'm going to put it over 1. How would we write that? Down 3 to the right 1. Okay, so 1, 2, 3. You can go that way, the hoop's on the right, or you can go the other way. It really doesn't make a difference. And then I'm going to go to the right 1. Like you can go up for the loop, or you can go down. It really does not matter. They're just little jumps. Okay. Ooh, 2 points make a line. Now, I want to do more, though, to make it more accurate. So go down 3. 1, 2, 3 over 1. Okay. So now it's going to make, oops, that looks pretty curvy. Now it's going to make a pretty great line. Okay. All right. Again, we're not looking for perfection here, but it should look like a line. And remember, there should be arrows at the end of the line, and it should be touching the edges of the graph. Extend that line to the edges of the graph. All right, go ahead and try that one and see what you get. Press pause and then come back. All right, so here's my y-intercept at negative 1. My slope is already a fraction, it's 2/3, so I'm just going to go up 2 to the right 3. Up 2 to the right 3. And there we go. Okay, I didn't make that line all the way to the edge. There we go. And there we go. You can keep those little jumps there. I want to see those jumps. Okay, I want to see those jumps. But before we go on, there's something I want to show you. Okay, so say if you want a more accurate graph. Do you see how we started at negative 1 and went up 2 and then to the right 3? Well, what if I wanted to extend my dots to the left more? Okay, like me, I wanted more dots over here somewhere, and I want them to be accurate. Well, my original slope was 2 over 3. Switch it to look like this, negative 2, negative 3. It's the same thing because a negative divided by negative is a positive. So what I'm going to do is go down 2 and then go to the left 3. So think of the opposite. Down 2 to the left 3. Okay, and there we go. A perfect line. And you can do that with the other ones from before. Let's look at our second graph. Okay, it was negative 3 over 1, but what if I change it to be 3 over negative 1? So I'll go up 3 this time. Instead of down 3 over to the right 1, I'll go up 3 and to the left 1. Oh, my line was not perfect. That's okay. That's why we can fix it now. Go up 3, 1, 2, 3 over 1. Okay, there we go. Definitely more accurate and more straight. There we go. And the graph 1 that we did, it was 2 over 1. So now change the signs. It was a positive 2, make it a negative 2. It was a positive 1, make it a negative 1. So now this means down 2, left 1. So down 2, left 1. Down 2, left 1. Down 2. As you can see, my line was not perfect, but it's pretty accurate by just redrawing it. So down 2 to left 1. So there we go. Now a much, much better line. Okay, so you can go the opposite way. So try that when you get to graph 4. Go the way that it's shown first, and then change the signs to go the opposite way. Okay, so go ahead and try this one out and then come back. Do both ways. Go ahead. All right, remember the first thing we do is look for the y-intercept, the one that does not have an x. Okay, negative 1/2 has an x. That's a slope. So positive 6. Okay. Now my slope is negative 1 over 2. So I'm going to go down 1 to the right 2. So that was down 1 to the right 2. So down 1 to the right 2. Down 1 to the right 2. Down 1. Okay, well, I can't really do that. Okay. But for the other one, I want to go the opposite way. So I'm going to do 1, negative 2. So because remember, this is still a negative fraction. That's still a negative fraction. So either it's at the top, the bottom, or in the middle. It still makes a negative fraction no matter what. So I'm going to go up 1 to the right. To the left 2. And there we go. Perfect. This one you only had 1 point to do for the opposite. Okay. So sorry, that wasn't a better example for you to try going the opposite way. But don't worry, there'll be more. Okay, well, what about this one? Oh, the last problem was y equals negative 1 over 2x plus 6. So remember how I mentioned on the last slide that it doesn't matter if it's at the top, the bottom, or in the middle, it still makes it a negative fraction. In the end, you'll still get the same exact line because it's the same exact problem. It doesn't matter where that negative is on the fraction for the slope. It's still the same exact problem. Watch. Go ahead and try this. Press pause and then come back. Okay, so we're going to go up to 6. And our slope is 1 over negative 2. So I'm going to go up 1 to the left 2. Oh, wow. I only have those 2. Well, let's go the opposite way. Okay, so it's the same thing as negative 1 over positive 2. So I'm going to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. Okay, if I go down 1, I only have 1 jump here. I don't have the second jump, so I could just stop there. And draw my line to the edges of the graph. Okay, so when you are doing the trick, I need to see the jumps, and I want to see you doing the points in the opposite direction as well. Okay, so again, all right, it doesn't matter if the negative is in the middle, if it's on the top. So let me just switch this to a 2 to make it easier to see. Okay, it doesn't matter if it's at the top. So it doesn't matter if it's in the middle. It doesn't matter if the negative's on the top. It doesn't matter if the negative's on the bottom. It still makes a negative fraction in the end. Okay, so it's the same exact thing. When there's a negative, think down and over instead of up and over. With more practice, this will make sense. Okay, so what I mean by up and over, like if I have a slope of 2/3, up 2 over 3, over to the right 3. Now, if it's negative, it's down 2 to the right 3. But here it would be, if I had it like this, down 2 to the left 3 because it's negative. Remember, the numerator I'll do this. The numerator represents up and down, up and down. Okay, if it's positive, you go up. If it's negative, you go down. For the denominator, okay, it goes left to right. So if it's positive, it goes to the right. If it's negative, it goes to the left. All right, one more for you to practice. All right, so let's look at this, graph 6. Whoa, that negative's in the middle. Where am I going to put it? Remember, it doesn't matter. Put it on the top or put it on the bottom. You choose. Go ahead, press pause, try the problem, then come back and check your work. Go ahead. All right, remember for this problem, it doesn't matter if you put the negative on top or if you put it on the bottom, you'll get the same answer in the end anyways. So I'm just going to go with the top one just because I wrote it first. I'm going to go to positive 2 for my y-intercept. Then I'm going to go down 2 to the right 3. Down 2 to the right 3. If I chose this one, that would mean I would go up 2 to the left 3. And look, that's the opposite way, which is a way I need to go anyways because I want you to go the opposite way. And draw the line through the points to the edges of the graph. And voila. Okay. This trick only works for linear functions, meaning lines. Okay, that the variable, the x, can only be to the first power. Okay, remember there's y equals x squared and y equals x cubed. You can even have y to the 6th power, but we're not going to see those right now. Okay, we'll definitely not see this one in 8th grade math. We'll see the squared and the cubic, but we will not see the to the 6th power. You'll see that in high school. Okay, so hopefully with learning the trick, you should be able to do it with practice in less than 10 seconds just by looking at the slope and the y-intercept. All right, so here's our lesson video outline. Okay, we looked at different functions. We use an XY chart. We use the trick. And now we're going to graph lines by finding intercepts. All right, part 3, x and y intercepts. Okay, by finding the y-intercept, we'll know where a line crosses the y-axis, at what point, and then with the x-intercept, we'll know where a line crosses the x-axis, wherever on the x. If it's here or if it's here, we'll know where it crosses. Okay, so here are the steps to finding those x and y intercepts. You're going to plug in 0 for either x or for y. So if I give you an equation, y equals 2x minus 6, if we're finding where it crosses the y-axis, well, you already know that because I showed you the trick. You just look, it's going to be at -6. But how do you prove that algebraically? How do you prove that using math? Okay, what you really are doing is plugging 0 in for x. Because look at, what's the coordinate of this? 0, -6. Whoa, what is the x value? 0. Okay, so you plug in 0 for x and you get this, so that is going to be your y value. Okay, so then, but how did I get 0 here? That's because we plugged in 0 for x. So 0, -6. For our x-intercept, you're going to plug in 0 for y. Why is that? Funny. Because it's where it crosses the x-axis. So if this is the x-axis at -3, what's that coordinate? -3, 0. What's the y value? 0. Y equals 0. That's what we need to do. Okay, so then if I have y equals 2x minus 6, I'm going to plug in 0 for y. That's what it's showing just right here on the left in red. So then I add 6, so 6 equals 2x divided by 2 divided by 2, x equals 3. So then if my x value is 3, what did I plug in for my y? 0. So my x-intercept is 3, 0. So now I know that when I graph this line, I need to go to 0, -6, and 3, 0, and now I can graph my line. Okay, as straight as a line as possible. That was not very good. That's not even better anyways. That's okay. Now I gotta fix it. Oh my god, I think it's because it's at the bottom of the screen and I'm writing vertically onto my computer. There we go. That's better, I think. All right, let's go ahead and go to the next slide. So find both intercepts for y equals 5x plus 15. Okay, so I'm going to split the screens for organization. So let's just say I'm going to find my y-intercept over here and my x-intercept. Whoa, how do I, which one equals 0? If I were to do my little point, which one's 0? Well, y-intercept, I can visually figure it out. Well, I know y-intercept is somewhere where it crosses the y. I'm going to pick a random point. If that were negative, if that were positive 10, what's the coordinate? 0, 10. Oh, it should be the x. Okay. Or think of the opposite way. Look, if you're finding the y, x is 0. It's the opposite. Okay. So if you're finding the y, you plug in 0 for x. If you're finding the x, plug in 0 for y. Okay. So let's go ahead. So y equals 5x plus 15. Y equals 5 times 0 plus 15. Y equals 0 plus 15. Y equals 15. So my y value is 15. So the y-intercept for this graph is at 0, 15. And we know that because we know the trick. Okay. But now let's find the x-intercept. Y equals 5x plus 15. Plug in 0 for y. Minus 15 minus 15, you get minus 15 equals 5x. Divided by 5, divided by 5, x equals -3. So -3, 0. If I were to graph this line, okay, here's my coordinate plane. I'll find 0, 15. So 0, 15 could be somewhere over here. And then -3, 0. -3, 0. And then I can make my line. There you go. Okay, so x and y intercepts are pretty simple. All right, it gives us a more accurate representation of what's going on sometimes, depending on what's given to us. Okay, so for the next slide, I'm going to have you practice that one on your own, finding the x and y. Okay, and press pause when you're done to check your work. Follow the same steps as before. Okay, go ahead. All right, so let's split it down the middle. I'm going to put my y-intercept on the left and my x-intercept work on the right. Okay, I should remember which one's which. Okay, so I'm finding the y, so 0 is for the x. I'm finding the x, so 0 is for the y. Okay, so y equals -3x minus 12. Y equals -3 times 0 minus 12. Y equals 0 minus 12. Y equals -12. So there we go. All right. Now over here, y equals -3x minus 12. 0 in for y. Plus 12 plus 12. So 12 equals -3x divided by -3 divided by -3. X equals -4. And put -4. Okay. So all you need to find was the y-intercept and the x-intercept. You don't need to graph it like I'm doing. I'm just doing it as a visual to help you visualize what's going on. Whoops. -12, and then this is -4. So there we go. So you can know what we're doing with this. What's the point of this? Is because it creates a line. All right. For those who can draw lines, it makes a line. Okay, remember your line should look a lot better than that. Oh my god, that looks horrible. I should really draw this at the top of the screen, not the bottom. Okay, well that looks okay. All right, go ahead and try the next one when I get to the slide. Quiz yourself, pretend it's a quiz. You're finding both intercepts for the next equation. And this is our last example. Go ahead and try that one. Press pause and then come back. So go ahead and watch me do this problem, correct your work, and check your answer. This is how I organize my work. However you do it is up to you. So remember, if I'm finding the y, I need to put 0 in for x. If I'm finding the x, put 0 in for y. Now I'm just plugging the 0 in for x. My y equals -4. So 0, -4 is the y-intercept. Now for the x-intercept, just plugging in 0 for y, solving for x. And x here ends up being 4/8, which I just simplify. It will not always be a whole number. So x equals 1/2. So my x-intercept is 1/2 0. My y-intercept is 0, -4. And my x-intercept is 1/2 0. Okay, hopefully you got that right. Next slide. Okay, so we've reached the end of our video. Remember, there are different functions. Okay, what we are concerned about for this lesson are linear functions. So functions that are lines, and how do we know? Because it's just to the first power. So whether or not you see the 1, it's there. Okay, no matter what, it's there. As long as it doesn't say something like this with a square over that x, as long as it doesn't say like a cube over that x. All right, so a 3 over the x, that's cubic. A square, a 2 over x is squared. So as long as it doesn't have those, it's just by itself, then that's what we're concerned about. We want just lines. Okay. Graphing lines using XY chart. We plugged in numbers. The most popular ones are -1, 0, and 1. We use the trick by looking at the slope and the y-intercept. Do the y-intercept first, then go up 3/1, turn the 3 into a fraction. If you're given a whole number, always turn it into a fraction to make it easier. Then finding the x and y-intercepts. If you're finding the x, y equals 0. If you're finding the y, x equals 0. Okay. All right. Have a great rest of the day. Bye.